designer draftspeople available to you to continue to upgrade those drawings. If you start losing those kinds of people, then it's very difficult to keep your drawings up to date. And that's probably a point that a lot of people overlook. They want a lot of engineers around, but then they maybe overlook the fact that they need designer draftspeople available too. In addition to drawings, we had the system design descriptions, or the SDDs, which are in book form and go into a lot of the original design conditions for systems, and go into that kind of thing. Lots of textual, descriptive information about the systems are included in those design descriptions. Those were kept up to date through the operation of the plant. In about 1992, it was determined by DOE that we no longer needed to keep them up to date as the plant started going into layup and then eventually shut down. So they were not then kept up to date beyond that time frame. But during the operation of the facility itself, they were kept up to date, and they do provide quite a bit of information about the plant and how the system's all tied together. The FSAR was kept up to date throughout its total life, and now that we're shut down, we've canceled the FSAR, and we're now into a documented safety analysis for the plant as it exists today in a shutdown mode. But those kinds of things were kept up to date as we progressed through the life of the plant.
Let me add one final point, if I could, which is not in the way of summary, but it's mentioning something that happens to be near and dear to my heart. Both Dave and Bruce talked about drawings, maintaining control of drawings and updating drawings, and mentioned the system design descriptions. And let me say a few words about the system design descriptions, or SDDs. I've worked on several projects since FFTF, none of which have had system design descriptions, and so I'm going to take the position it's a lost art. And I'm going to give an indication of what we lost when we lost the art. System design description came out of naval reactors. It's basically 7 different categories you write to in there: functions and requirements of one, casualty events as another, casualty events being upsets and safety-related events that could cause damage to the system, whatever it may be. FFTF had 70-some major systems, each one of which had a system design description. On projects that I've worked on without system design descriptions, it becomes very difficult to add a new engineer into a group and have that engineer become productive in any reasonable amount of time. With system design descriptions, you can add a new engineer, and you can hand in a system design description. He has a body of knowledge that is common to everybody else in the group. He can go to work quickly, contribute from his own knowledge and experience, and become a contributing member. Without system design descriptions, I found that's very difficult, and the whole project has suffered because of the lack of them.
These principles just summarize much of what's already been discussed here, but it sets forth for a new project coming on. These are principles that I would think should be set forth and looked to in establishing a project. Discussion of the FFTF experience should recognize those principles underlying the record of safe and reliable plant performance. They include well-defined and established contractual relationships, confirmed work scope, and full funding. The contractual, when the project was estimated and put under the FFTF project office, the contracts with the operating contractor, with the design contractor, and with the architect engineer were changed to become cost plus award fee contracts, so that they were incentivized so that award fees would be based on performance against established goals and objectives. And that was done successfully throughout the project and was a contributor to success of getting on time and within budget in bringing the project online. I mentioned rigorous design and configuration control. We've talked about that considerably. Implemented by plant engineering staff, in-plant engineering staff. Carlisle engineers work closely with the operations and maintenance staff. Configuration control is maintained through rigorous change control procedures and the maintenance of accurate, formally approved system design descriptions supported by the FSAR documents. Supporting the FSAR documents. A dedicated technical support staff, knowledgeable and competent in the reactor, fuel, and plant design, and the underlying fast reactor engineering and liquid metal technologies. A highly competent operator staff, we've talked about that, developed and sustained through adherence to rigorous selection, training, and qualification standards. And finally, independent review and design, review and oversight of nuclear safety aspects of design, operations and maintenance of the reactor, fuel, plant systems, and maintenance, and irradiation test vehicles, conducted in close coordination with facility operations by both the operating contractor and by the government.
Do you care to add anything to this, Bruce?
Well, just this point. New projects come about, people are assigned to make them work. And today that can be a very sobering assignment. Maybe be made more difficult by the advocacy of shortcuts. We didn't feel that pressure to get it done anyway. However, you can do it by that date, and you better do it by that date. We instead were benefiting by discipline, documentation, thoroughness, safety, quality, and we had people who joined the team with those things in mind. I think it may be more difficult today to do a startup on a big plant, like the vitrification plant, unless you have a lot of support from above to do it right. So we benefited from the guidelines of the project. And I appreciate the chance to share that with you.
If we really think about lessons learned here, I think these are very, very important principles. The IAEA has had over 50 nations express an interest in becoming a new entrant into nuclear power. Over 50. And the Director General, Amano, has said that probably somewhere between 10 and 25 of these nations will have an operating nuclear reactor by 2030. China is currently building 24 reactors as we sit here. It's an incredible new interest, and the question is, can this kind of rigor be applied to this fleet? It's a huge human resource issue. Because we know in this business, an accident any place is an accident everywhere. It demands discipline that no other industry has ever demanded. We were very fortunate in this project, as we've all talked about here, that there was a lot of enthusiasm. This was the central thing. This was the central advanced reactor program in the nation. All the national laboratories and industry had a role somehow. But it was all very disciplinedly kept under tight discipline to make sure that it all fit together. This is probably not going to be the situation as when you're thinking of building a whole raft of new power plants. There's going to be pressures politically to get these things going. And so I think it's very, very important that people learn from these principles, and so that in fact we do allow nuclear technology to benefit humanity in the way it can, as opposed to having an accident someplace because we've decided to skip a corner someplace. So I think these are very, very important principles.
I guess if we're summarizing, I'd certainly like to thank our panel for their knowledgeable and very enthusiastic contribution. And I'd like to thank our project manager, Diana Love, who maintained contact with Kim Basso, and kept nudging us in the right direction so her project would not become an orphan in our laboratory. Thanks, Doc. I would say one important message that maybe stands out in parallel, maybe somewhat above all the others, although I'm not sure it's above all the others, is really the importance of this project and the importance that it played in our lives and our careers. It's been mentioned that this project was, for us, one of the highlights of our careers. We're proud of it. We're proud of our colleagues. We're proud of our success. It's important, it was also recognized by our families who had to pay a certain price here because of the long hours in which we worked. It was important to the nation because it has to at least develop this technology in some form, although it may be preserved for a while before it's carried on. And we're certainly proud to have participated in this project.
I think one of the important things that I've taken away from my activities working with FFTF is the importance of the communal or the dealing with other people and not being afraid to bring other people in to attempt to solve a problem. I think that the team approach at FFTF is instrumental in things that were done. I believe that it was often very evident. You walk up and down the halls, you find operators in engineering offices, you find craft in engineering offices, you find engineers in operators' offices out in the field all the time. And I think that, to me, was probably one of the key issues working at FFTF was the communal approach, the family approach that was there, and lots and lots of good friends that you develop.
The thing that was unique about FFTF to me was because we all had the feeling we were doing something significant, really significant. I think everyone felt that, and this was what drew some of the best people here. At that time, we really felt that we were going to be building fast breeder reactors like peas in a pod, one on every service station corner kind of thing. Not quite, but since that time, we've discovered more uranium, and we've gotten very hooked on oil and so forth and so on, and somehow there's been a lackadaisical attitude in this country about energy. But now we're getting back to the point where we're taking this very seriously at the very top levels of government. And worldwide, there's still, energy is still a huge issue. In fact, well over 90%, probably 95% of the energy that we know how to harness is in uranium. But we really need the fast breeder reactor to get us there. It just dwarfs coal or fossil fuels. And of course, it's a long-term source that's compatible with environmental stewardship. So I would say to young people now, this is the time to get into this business. But the bottom line really in all of this is a very, very deep, direct sense of safety culture. Again, this is something that's hard to instill, it's hard to measure, but there are different cultures around the world that view things quite differently. And I think a couple of years ago heard a lecture on safety culture that got me in the gut, and that's where it has to get. It's not a program, it's something every individual, whether you're a craftsperson or the plant manager or whatever, have to understand this is a different technology. It is a beautiful technology, but it requires incredible focus on safety, and you have to empower individuals. If there's an issue that they see, that they have the power to stop operations or whatever. This is something that's very, very important. It's a big challenge. How are we going to inculcate this safety culture as we go on? But that, to me, is what I got out of this project. It's a great brand new world, and what an experience, what an experience.
Just to follow on to what Alan was saying, I would make the point that there is still a lot of political and public confusion concerning if the place of reactors in the closing of the nuclear fuel cycle, the fast reactors in the closing of the nuclear fuel cycle, and also in the inherent safety of the business. These are impediments, along with economics, that have held it back. there is indications now that they come to life again, and that's great. But the underlying concern, I think, in getting it going along with, as I say, the problem of demand and economics, is the confusion concerning how it fits into the waste and fuel process available through the fast reactor technology. Perhaps we will get to see a straightening out of that slowly as time goes on. That's my point.
I would make 2 points. I think the scoping and defining of the roles of the key organizations must be explained, settled, and communicated all the way very early in the project. Get those questions of who's going to do what and who's going to be responsible for this or that. Get those settled. Decide what operation is going to be responsible for, test engineering, the construction people, so on. And the second thing I would suggest is that there be a realization that to build an organization, you've got to recruit key people very carefully and then mentor them intensely. Mentoring, mentoring, mentoring. Getting close and being open with them and having it become a friendship. Those are the things I think that help build the organization from the start.
Just a few words on the fast flux test facility, something we are talking about